Dear colleagues, it's a pleasure to participate to this very exciting meeting on hypothalamic hamartoma, and it's really a fantastic program. And I do apologize for not being able to be with you in Calgary. A few words about the Human Brain Project. It is one of the two European flagship research projects which primary aim was to develop and use novel digital tools to boost neuroscience research, in particular to advance multi-scale model and simulation of neural networks, taking advantage of facilitated access to high-performance computer. But it also enabled to advance and develop novel analytics for brain health data, as I will show to you in a minute. Now, HBP will end in a year, but it's not over. On the contrary, it's being continued by eBrains, which is a sustained European research infrastructure that will continue developing and operating the different HBP platform. For clinical neuroscience, for epilepsy, for hypothalamic hamartoma research, the Ryvlin platform are the so-called medical informatic platform, the MIP, human intracerebral EEG platform, the HIP, and the virtual brain model, the TVB. Let's start with TVB. TVB is primarily an MRI-based connectome, but which is enriched by a neural mass model that incorporates multi-scale biological information describing how neuronal assembly and the glial and extracellular environment operate. Furthermore, it enables to simulate the brain and EEG activities that the model will generate, and to compare this simulation to the real data, to the grand truth data, which in our case is the intracerebral EEG data. Now, in epilepsy, it could help delineating the epileptogenic zone, as was suggested by some preliminary data. And the Marseille group, who is in charge of developing the DVB, is now testing its clinical impact on epilepsy surgery outcome in a very ambitious randomized controlled trial that will include more than 400 patients. TVB can be used to study hypothalamic activity and connectivity, as illustrated by this work. And I think that hypothalamic hamartoma connectivity is a very important topic to better understand the organization of the epileptogenic network associated with those hamartoma, understand some of the epilepsy surgery failure, and eventually get better result performing surgery in that condition. Some important work has already been done in the field, using, for example, EEG fMRI and dynamic causal modeling to study the propagation of seizures from the hamartoma toward the cortex, and in that case showing, in a single case in this report, that seizure primarily propagated from the hamartoma to the posterior region, that is a temporal-occipital region, and from there to the more anterior frontal and cingulate brain region. Another very important work, which has been performed by our co-chair, is using resting state fMRI to delineate those aspects, those part of the hamartoma, which are connected with the cortex and which are suspected to be the epileptogenic portion of the hamartoma. This is really a very exciting work, very impressive, in particular in terms of findings, because based on this result of the hamartoma connectivity with some cortical area, the others have then targeted the specific subregion of the hamartoma with a laser ablation, and by doing so, they were able to get up to 92% of class 1 outcome using the angle classification versus only 47% when using a standard approach with the lead not guided by the resting take fMRI finding. So I believe this is a path to follow and for which the model and the simulations capacity of e-brains, including the virtual brain, could be useful. And I'm sure that must have already been discussed between Jean-Régis and Victor Girsa, the two persons involved in hypothalamic hamartoma surgery and the virtual brain in the group of Marseille. The second e-brain platform, which could be useful for leveraging research in the field of hypothalamic hamartoma, is the MIP, illustrated here through its user interface and its epilepsy surgery data model. The MIP is all about federating dataset which cannot be centralized. There are indeed several models of health data sharing. The most common being centralization of data, as is being done, for example, in Epi25 very successfully. Another approach is the also very successful model of Enigma, where data and analyses are distributed in the different center, and then in a second step, the findings from each center are centralized to be pulled together for final analysis. But with the federation model, which is illustrated on the right-hand side, all datasets are connected, and in the case of the MIP, connected live, permanently. So most importantly, the data strictly remain in their original location at all time, including during data analysis. But their interconnection enable accredited user to query the different dataset simultaneously and to perform various analytic, including machine learning, on those different dataset in order to get a pooled findings. Importantly, users only have access to a secured web-based interface that only allows sending queries and then receiving aggregated findings from those queries, but they cannot at any time enter the dataset themselves and to have access to the individual data. So the latter remains fully protected. Those are the main specification of the MIP, which is currently installed in 50 neurological centers in Europe, including many epilepsy centers from the European reference network EpiCare. It is also being part of a partnership which is developed with the European Academy of Neurology and the European Stroke Organization. And for instance, the MIP is being used to federate national stroke registry, which cannot be centralized. So provided the existence of several datasets of hypothalamic hamartoma, which you would like to federate and analyze together, and which centralization will either be not possible or too complex for regulatory or ethics reasons, the MIP will be the appropriate tool to enable those type of federated analysis. Finally, the third platform of interest for the minority of hypothalamic hamartoma patients investigated with SEEG is the human intracerebral EEG platform, the HIP. But I won't have the time to elaborate on this today, inasmuch as it is planned to present the HIP in detail tomorrow. So, in conclusion, several HBP eBrains platform and services could prove useful for researchers working on hypothalamic hamartoma, from the virtual brain to the MIP and HIP, and I will be more than happy to help any researcher who will be interested to use this platform and get access to this solution to this purpose. Thank you very much for your attention.